Yeah, so should I start, right?
Mhm.
So I prepared two parts for this talk, but maybe we will just start with just one part. First part more personal, second part is more general, and I'm not sure if we have time and energy for the second part. But so maybe I use it as a kind of backup slides, and then during our question sessions, I probably will use it. So it means that in the question sessions, you could ask any type of questions regarding publishing. So I'm like not super expert, like I'm not the most experienced person, but I also think that sometimes it's useful to hear from people who are not very, famous yet. Also because there is this survivorship bias. So for example, I don't know, when I was asking Soon about success yesterday, and like he answered the first part about luck, I completely agree. I actually always have this in my slide. And then he was always, I think, saying about like being bold and trying kind of this more radical ideas. But then you never know, right? Maybe it works out for him, but for 1,000 other people who will also try these bold ideas, it won't work out. And yeah, it's kind of hard to know. So maybe this is my perspective from not super famous successful scientists that also can be interesting to you. Anyway, I should start sharing my screen. This is my screen. And I should present this. So I will start with this paper that we actually written together with Lisa some 2 years ago. So what we were doing in this paper. So this was, I think, by formal criteria, our most successful paper. That's not actually my favorite one, but in this paper, we're using data from VK. So most of you, I think, know this is just basically Russian Facebook, very popular social networking site. In Russia, there is more than, I think, already 100 million active users. And what we were thinking, we wanted to study parents, trying to kind of to understand something about parents and to use data from VK. And before that, I was using VK data to study students from universities and from high school. And for this type of people, it's easy to use VK because they just indicate in their profiles that we study in this university. So it's like very easy and straightforward to collect data. But for parents, there is actually a field to indicate that you have children, and you can indicate links to their profiles, but most of users don't use this. So we wasn't sure how we can get data on parents. And so we have this idea, maybe we can look at people who mention children in their posts. So if people saying my daughter went to school, then probably this person is a parent. And that's why what we just plot, I think that was really like a very quick plot. We do this, I don't know, in one day, a few hours. I think Lisa just plotted this, the first version of this plot. Just, I already have this data set of some users, and we see how many of them mention at least once words related to sons and daughters. And we have this plot that's pretty nice curve with some expected age-related patterns. So you see this increase starting from 18 years, some peak around the time when most people have small children or just have their first children born. Yeah, and then when you have this plot, it is very natural to split it by gender, right? That's what I think many of us would decide to do. So that's what we did. We split it, and we see that there is a bit different patterns for men and for women, and that we also see that women mention more often their children than men. Everything is expected. And then finally, we also thought, okay, now let's just split by gender of a child. And I think we wasn't sure what would be the pattern. I think I was expecting to see some, I don't know, heterophilia, like, I don't know, maybe, I think anecdotally people sometimes say that women are more attracted to sons and men to daughters or something like this. So I was expecting to see something like this. But what we will see instead, so we see that both genders talk more often about sons than about their daughters. And that's basically what that's the main result from the paper. And then we write this paper. And then after it was accepted and then published, I feel like I have like weird feeling of, I don't know, disappointment, because it's, I mean, it's like so simple. I mean, I was thinking anyone can do it. I mean, what we were doing like a few days ago, we were also doing this basic Twitter edit data. It's exactly the same. And so I have this strange existential crisis, like what I'm doing. Maybe I'm doing just ridiculous thing, why it's even called science. But then I was also thinking that empirically, that's probably not true. Just if you look empirically, this journal is like pretty selective and it's prestigious. There is a lot of incentives to publish there. Like for instance, I don't know, in High School of Economics, if you publish in journals from first quartiles, they give you like tons of money, like 30,000 euros. That's like crazy amount of money that you get. So there is incentives. So people should try to publish there. And there is also incentives outside our university. Maybe not money incentives, but that's really improves your career prospects. So probably people try to do something, but not everyone is successful. And then, of course, one reason, I think the main reason is just luck, but also maybe there is something more. I mean, luck could help you to some extent, but you know, if you have just completely nonsensical results, then not any amount of luck won't help you to publish in, I don't know, Nature. It's not how it works. So I was starting to think about it. And that's what I want, these reflections I want to share with you, that I think what was important for this paper. And I would like to start with 3 components. I think the first of them is data, then methods, and then theory. So let's start with data. So I think we talk a lot about this importance of these new sources of data, I don't know, big data, etc. But because often we see just the final results, it's maybe not so clear why it's really important. And so that's why I wanted to show you some like intermediate results. It probably should highlight the importance of these large data sets. So for this plot, what I just do, I just create the same plot, just proportion of users who mentioned sons or daughters, but I just selected not the whole data set that we have, but just 100 people. And so you see, well, you see nothing, right? They're just, you know, random things. You cannot do any sort of analysis on this data. And then, you know, you can increase this to 2 or like 400, it's still just kind of nothing. With 1K, yeah, I mean, I think it's still nothing. With 2K, maybe you see this kind of increase, noisy increase, but still there's not many people in this upper region. And it's still not really impossible. And now here I'm not even splitting this into 4 parts. So if I start to split, and then I will have just noise, and then I will increase to 4K. And with 10K, you start to see something, at least in this region of young ages, you start to see clear patterns, and you can increase like to 20, 40, 100K, and then 200K, you already have curves that looks nice, and then you probably could split. And I think our data set was around 400K. I think it was 600 probably. So yeah, I think that's kind of highlights the importance of this large data. So if you have this 2K, you just cannot do this type of research. You just get just noise, just errors would be too large. You won't get any significant results. And with 400K, you even visually can see clearly what's going on. And then, of course, if you apply, usually you don't worry about statistical significance because that would be really small p-values. You can correct for multiple comparisons for anything that still will be small enough, so you don't really worry about these things. So this is important of this large amount of data, but there is, I think, much more related to the data. And I think we already discussed it briefly when we talk about other sources of data. And that's related to the fact that you really have to understand your data really well. And so this is the plot that I created when I just started to use data from Wiki. I just have this idea to use this data. So what I plotted here, I just use my own school, my own age cohort, and I just downloaded profiles of us. There is me somewhere, and that plotted our friendship network on this website. And this is what it looks like. And there were several key observations here. First of them was that we actually finished our school even before the site was created. But still, because of this popularity, like all of us were there. Moreover, almost all of us were connected to each other. So It means that today's high school students and university students would be with very high probability there. So before that, I wouldn't even start to download data because I wouldn't be sure if there is some interesting information. And then another very important thing here was that there seems like a lot of fake profiles. So this is users, this reddish is users that I don't know. So, and I mean, it could be that I have a very bad memory. I just forget everyone who was in my cohort. But it more probably just some fake profiles. That can be bots. That can be just users who just indicate our school for some reasons. But it also seems that it's very easy to actually to sort these two groups out. So basically, if you exclude anyone from this connected component, so that would be a very good filter. You will exclude almost all of these bots. So for these 3 dots, I don't know. Maybe it's just bots who were successful in friending some of us. I don't know, maybe it was someone just, I don't know, changed their last name and that's why I don't know, the photo on avatar was, I don't know, some cartoon and so I don't recognize them. But these 3 people are not important because we see we have this very good filtering ability. And that was initial insight. And then what we did, we do a systematic study using data from one school in Moscow where we know both the accounts on VK like real names and we were matching them. And we also building this network of these high school students from one Moscow school. And we see there is some nice patterns of different people from different classes. They are always kind of clustered on this picture. Also, we see this, it seems that there is kind of 2 main clusters and it's initially we were like confused what it means. I don't know if it's US, in US, that would probably be some division by racial lines. So that's what you usually see in the plots from US. But we're also thinking, I think briefly, maybe that's girls and boys. But then we realized that this school is actually comprised of like several buildings, and this was actually 2 separate buildings. That was also nice to see that these real life divisions are reflected in the school. And from this, first of all, we confirmed that this is a very good way to filter out fake profiles. So there were also many people who indicated that they're from the school, but they were not in the list of real people from the school, and they were also not really connected to this main network. So we confirmed that, and we also compared 2 groups of people because not everyone is on VK. Well, almost everyone is on VK, but not all of them indicate their school and their profile. So we were also kind of comparing people who we found on VK, not found, and then here we just checked that there is no significant difference, and that was important for future research. So we were more or less sure that when we select people who indicate their school on VK, that these people would probably not that won't be too biased sample. And then I was repeating the same. So here I was repeating the same with our whole university, High School of Economics. So this is also profiles from VK. And you can see that we have 4 campuses and 4 cities, and they were clearly separated here. Also, different years of study was clearly separated. And these small clouds, I don't color them by different colors, but this is basically separate educational programs. So if you color by educational programs, you will realize that this cloud is actually one educational program. So that helped me to better understand this VK data. And then after this, I was collecting large-scale data set when I was collecting everyone from St. Petersburg who indicated their schools in their profile. And so I collected this very large data set. So this is all schools in St. Petersburg. And connections here is if people from the schools are connected to each other. Yeah, I just wanted to add some curious results related to this. So what we found there was that the probability of a friendship tie between schools is actually closely related to the distance between schools. Yeah, you can see it's like exponentially decline. So if schools are close to each other, then almost with probability of 80%, students will be friends with each other, and then it's quickly decline. And in the paper, when I used this data set for the first time, I was looking at kind of interested in segregation of schools. So I was looking at a school, and then for each school, I know average academic performance of its students. So I kind of know which schools are high performing, which schools are low performing. And then I was comparing the results of a school and its geographical neighbors. This is from the left picture. And I see there is no correlation. So that's probably picture would be very different, I think, for US. For US, you know, if you know the zip code of a school, that would predict with very high probability academic achievements of its students. I think there is nice visualizations related to this topic. And in Russia, or at least in St. Petersburg, it's not the case. So you can have like a very high performing school, and just across the road would be like very low performing schools, and there is not really residential segregation as for now. I think it's slowly increasing, but probably due to this Soviet legacy, we still have no problem. But then in digital space, when I do exactly the same analysis now, instead of geographical space, I was looking at the schools that are most closely connected in the digital space. That just basically means they have the more friendship connections with each other. And then the picture was completely different. So the correlation was pretty strong here. And yeah, that's, we can, because we know with this network studies, it's kind of can be hard to check a null model. So maybe you can say that maybe this correlation is derived by some geographical constraints, because we already know that these connections between school actually determined by locations. And I was generating this a lot of random networks that are not completely random, but that actually follows this real world distribution. And then I checked that if you generate these random networks that would be geographically very similar to real school network, you won't have this effect that allow me to understand that this effect is kind of real and not explained by geographical constraints. So, you know, that's I also like, as soon as I have like very long preamble. So why I was telling this? So because I would have experience with collecting these data sets, and here I decided that I can look not only on current students, I can just try to download it for all ages. I was just collecting this systematic data set when I was for each school and for each age cohort. I was downloading all people who indicated the school profiles, and I was removing everyone who is not connected because my suspicion was that was some fake profiles, and I collected this data set of about 1 million users. Then I also downloaded posts of all these users. That was around 1 billion words, pretty large text corpus. And so I use a systematic data collection approach instead of just randomly picking VK users. And I think that was pretty crucial for the next result. So my first attempt to analyze this text data was very simple. I was interested in comparing the average word length for different ages, because like this is a proxy, simple proxy for text complexity. And then because I was working in the field of education, people was always complaining, you know, people use the social networks, they become more and more stupid, they try the stupid short, you know, text, etc. That's just nonsense. That I wanted to check this hypothesis, so I built this plot. And also here we can see some expected patterns, like that with age, word length is growing up. And what's more interesting to me, it seems that with each year, there is also this growth in words complexity. And there is also this interesting huge gap here. And that actually was exactly the year when there was a very large change in VK functionality. So before that, this feed was just your own, it was called like wall. So it was kind of your private, you posted it in your profile, and then you need to go to the profile of a user to see it post, and then it became a newsfeed that is common also to Facebook nowadays. And that was exactly, this change was also reflected. And I was actually also zooming in here just to identify the exact months that is responsible for this huge gap. And this was exactly the months when this change was made. And why I'm showing you to this, because I know at least, I think, 3 attempts to do the same. So I think that there was one paper and one master thesis and another work where I see that people was also trying to see how the length of works increase. And in both cases, they see nothing. They see some random weird fluctuation. And my hypothesis, this is because they were not collecting this. First of all, in some cases, sample was too small and you needed to be large enough to have this nice curves. And another thing, if you just collected it in some kind of random non-systematic way, that can be some bots that would completely skew your results. And so this plot won't be possible without all the previous work. And without this plot from parents' paper was also not possible because you see this is like pretty similar plots, right? So I think we, when we first discussed this parenting, this idea came to mind almost immediately because we already tried to do something similar. So that so here I'm just trying to illustrate using real world examples that you really need to know your data. Because it's, I mean, I think we already say these words aloud, but one thing is just say them in abstract, and another is maybe to see how it was really, one thing was leading to another. So then maybe I will take a pause between this data session because there was already one comment in the chat. Yeah, so maybe we can, but maybe there is some, I don't know, questions because I was already talking for some time, or maybe comments related to this part.
So maybe we can discuss Yuri's hypothesis. No?
I'm okay with that. I don't know if Yuri want to share it now or later.
Mm-hmm.
Well, it's completely up to you. So do you hear me well?
Yeah.
Oh, yeah. So in Russia, it's quite common that well-performing students each year take part in competitions like school Olympics and different other competitions for math, for language, for biology and other disciplines. So, and I assume that usually schools send the most successful, the most smart students to take part in these competitions. And probably during these events, they meet other students and pupils and establish connections and ties there. So this thing can make it possible that highly performing students make digital friends, and this will result in this interesting correlation that higher performance students can make neighbors without any kind of geographical particular location. So that's a small thought.
Yeah, and thank you for that. It's actually related to this publishing topic that because so this paper was published in PLOS One at the end, not so selective journal. I published it. I sent it before to some more selective journals, and the response there was, I think, universal. So they say that they like this paper, but they think it lacks explanation of why it's happening. So, so that was the main reason for rejection. And so, yes, I think it's important to remember that people usually don't like this kind of results without explanations. But then I wasn't able, I mean, I could hypothesize to create some hypothesis why it's happening, but I wasn't sure how I can really check them using the data. And maybe I was also a bit lazy to think about it. But it's kind of important thing. So people often expect you to explain things. And I think there's another question or comment.
Just another comment to Yuri's one. So the other explanation for that might be that those people who are with high academic performance, they tend to change schools, you know, like go from original school to some gymnasiums, so like apply there. So they do change the school, therefore they know people from the one they applied, like they were grown up, and the other ones like more selective, therefore they have a huge network. Yeah, and this probably might be checkable hypothesis through knowing how many schools, if they do have opportunity to mention several schools in VK, I'm not sure. So people who
Yep.
change schools might have higher academic performance. Yeah.
Yeah, for that reason, I was excluding people who indicated several schools. But it's also, I cannot still exclude this hypothesis. Maybe they just indicate the new school. And yeah, so there is this kind of this magnet. So usually the highest performing schools is magnet schools, and in St. Petersburg there's like several schools that I think some of them even admit students only after 8th grade. So usually they collect students from all other schools. So that could be partly explaining. So I don't know if I would, I don't know, maybe I should, a few years ago present this to you, and then you will generate hypotheses, and then we will think together how to check them, and then we could improve this paper, and then probably it will be published in a better journal. Who knows? But I also like at certain point I was too tired with this paper, and I also was writing it alone. And this is also one thing that I don't recommend you to write solo papers. That is super hard. And yeah, solo papers are very hard. It does sometimes you have this low stage, and then usually if you are in low stage and you're writing with someone else, they just these people just just add a few lines, edit something, and then you can already return to this text, and you see it's already was improved, extended. But then when you're alone, that's really difficult. For some reason, I have a lot of solo papers. I don't know. I hope to fix it in future. Another thing was related to the methods. So I just mentioned that we look at this mentions of son and daughters, but I don't really explain how it was done. And this is not so trivial task if you think about it. For instance, we were looking at the word daughter, for example, but then daughter not necessarily means a real daughter. It's not necessarily offspring. That can be Gazprom daughter. That means subsidiary of Gazprom. That would be also called daughter. So we need to deal somehow with these false positives. So here it wasn't very, creative. I think we just selected a random subset of posts, and we just manually, I think there was 5 people. We just manually was counting how many of these words are false positive, and then we just count, and then we realize that if you compute, then this number of false positives cannot affect our results much. That was our approach to this. And we were a bit more creative with dealing with false negatives. So because this is VK, this is not some Wikipedia text, not news text, when all text would be written in this perfect words. People can write words with spelling mistake. So, for example, for those who speak Russian, there was this word dochka, and some people was using mягкий знак in the middle. So this is not correct spelling, but a lot of people do this mistake, and then they can write all sort of very weird words. They can say dachuring, whatever, any weird song. So they can write like son, like with many O, when they were celebrating its birth. So we need somehow to be able to account for that. And so idea here was to use word embeddings trained on VK. So instead of using pre-trained word embeddings, we train them on VK dataset. And this word embeddings, they kind of automatically allow you to find words that are used in the same context. And so then we were looking at the closest vectors to the vectors corresponding to son and daughter, and we created a huge list of similar words. Then we filter not related words, and that's how we created our dictionary of weird sounding words. And then we used this dictionary. I think we used several dictionaries, and we also tried to vary dictionary size, so just to be sure that our results are stable in this respect. And what was interesting also about here is that we didn't train this specifically for this paper, that I was doing it before for another paper, that I already have this model trained. So I have this paper when we try to predict academic performance from text of posts. I don't want to talk a lot about this, but I was just using, this is pretty common approach. If you want to predict something using text, you usually train this word embeddings. So I trained the model on that. We have some data set where we have both academic performance of students measured by some standardized test, not their grades, because grades would be a bad measure of academic performance. Maybe we can talk about it next, because I think it's related to this fragile family studies, because I think some of their results could be explained actually by the fact that they use very bad variables. So, but we have access to very good variables, we train the models, and I also applied it to, I don't know, 100 most populous Russian universities, and was trying to predict academic performance of these universities. Not academic performance of universities, but when people go to universities, they pass the standardized exams. So for each university, you know, average performance of its people who enroll to this university. And just from digital traces, I was able to achieve pretty nice, I think, performance, like this correlation between predicted score and real score. And just illustration of words that was the strongest and not so strongest predictors of academic performance. So horoscopes was really predictors of really low performance, and some things related to Harry Potter universe was among these words indicating high performance. And there was also funny things that you can even create some hierarchy between words. Like when this is for alcoholic drinks, you see wine is better than beer and better than vodka. And also you can look at this, some political words, like compare Navalny and Putin, and see, you know, if you're mentioning Navalny, you are probably smarter, at least better performing. And I think this was actually, I think that's not what, that was not super important in terms of real results. I think it just was just some controls. The main result was holding, and what we tried, it's not really affected the main result. But I think that was important for reviewers and for the editor. So because you use this kind of smart thing, I mean, that's the science not necessarily works like in this perfect, I mean, in an ideal world, you would say, okay, methods should not impress editors and reviewers. It's shouldn't work like that. But I think it kind of helped, because this was also, I think, popular. So it was published in PNAS, and around the same time, there were several papers that was using word embeddings to study social phenomena published in PNAS. So it seems like there was kind of this, I know some of how you say this word in English, fashion for this thing at the time. And I think that's probably made some impression. So I would not recommend you to try to impress someone, but I think it's important to remember that sometimes, you know, there is this fancy method and you can use it, and your paper will have higher chances of publishing. And that's also true in reverse. So there is some methods that actually can be very good, but they are obscure. And if editors and reviewers are not really familiar with these methods, they could dismiss your work. So yeah, you have to follow what people doing, what methods they're using. And this is especially true for outsiders like us. So if you are like super famous person, like our guest people who they publish, like, I know, each day a paper in top journals, then you can start some revolution. You can introduce new methods, and people will listen to you. But if you are outsiders, that's very hard to do these unconventional things. It would probably increase your chances for reject. And that's, I mean, this sort of things is kind of hard to tell, because I want to tell only ideal things, but also I want to tell like some reality of scientific publishing. And the final part is related to theory. And I think its theory is very important. And that's not always clear for like people from computer science background. Well, I myself with computer mathematics background. So why I think theories are important? First, they, I think, help with kind of understand where to look. I also was thinking about our paper. So there is so many people with skills in computer science skills. And the data from VK is public, it's available via public API. All of them has access to this data. All of them, you know, can download it. Most of them have more skills than me. So why they were not like publishing tons of papers? I mean, some of them just not interested in publishing papers. They're working in industry, but still, it wasn't clear for me why there is not so many papers using VK data. I would expect much more papers would be published, especially given that we have a lot of computer scientists who are very skilled in this. And I think one reason is because when you have a data set, there is like infinite, unlimited number of ways that you can analyze it, right? So, and when you realize that there is infinite number of ways, then you realize that the ability to select one way and just to choose one question, one exact way to conduct your analysis is really important. And that's where theory kind of help to guide you. For example, like for us, it was pretty obvious that this is an interesting direction because we know about gender inequalities. So we know, for example, that sun bias exists. And there is a lot of research related to sun bias. So we know that, I mean, in the worst form, that could be sex-selective abortions that still exist in some countries. Also, we know from research that women tend to breastfeed their sons longer than daughters. Parents also spend more time with sons. Men are with high probability will marry a woman if they have son than if they have daughter. And if they're already married, they will high probability will stay in the marriage. And also parents invest more in sons than in daughters. I think there are some changes, like recently in some countries, there is some improvements to these characteristics, but in general, if you look on overall picture, there is this sun bias. And so because we know that this problem exists, it was easier for us to understand that this is actually interesting question. And we also know that female characters are underrepresented in the books, movies, textbooks, and that helps us to have the context for our research. So now we know, okay, now there also seem to be, we have this new media, social networking sites where people spend so many time. And now we know in this new media, there's also this problem with underrepresentation. It's kind of was creating this context for all of this. Yeah, and also I just skip here. After helping you to decide where to look, it also helps you to interpret your results. And this was actually not our ideas. That was actually what our editor of the paper suggested us to actually include in the paper. And that's also one interesting thing regarding the publishing. So if you publish in a very good journals, so then this review and editing process, that's something that usually really helps you to make your paper better. So if you publish like in random journal, they often just, from my experience, they usually what they ask is makes my paper worse. They just ask, you should definitely add this stuff, and this stuff is completely unrelated. I really don't want to add them, but then I realize that they will reject my paper if I don't add it. Again, when I'm more famous, powerful, I may try to resist it, but at the early stage, that's maybe not wise to resist it. I mean, I would resist if something would be completely wrong. So I would never do something that I think is wrong. Something that I think is okay, I would prefer not to do it, but that's okay to add this paragraph, I would probably do it. And in this good prestigious journals, and that's not only my experience, it's also experience of my colleagues, they really help you to make your paper better. And so the editor of our paper, she really helps us to make it much better. So after it was, after the first, I think, well, I mean, first reviews was very helpful from her and from reviewers. And the second round was even more helpful. So the second round, they already decided they want to publish it. They were just suggesting us to improve things. And I think she even like suggested us how to rephrase one sentence from abstract to make it like better. So this is like really not often happening in other journals. And I will answer the question, just I finish without this framed by gender picture. So there is this kind of large question in this gender studies, that's why gender inequality persists. Because it's improving. There was like a lot of improvements, especially in 20th century, but still, and after that, it's kind of progress kind of stalled. There is some very small improvements, and in a lot of areas, we just stuck at some disadvantage for women. And the author of this book, she has a theory that the problem is in some everyday micro interactions, and that's maybe doesn't matter exactly what it means, but because this is kind of micro interactions every day, you can guess it's very hard to capture it with survey data. And so our editor was, I think, saying, you know, this is very hard to capture this empirically, but that's what you were able to do. So you have this everyday interactions. We also look at likes to this post, like likes, posts. And so now you have this illustration for this theory, that's why it's important. So this was this interpretation layer that I think was also important for the final result. Yeah, so I think there is a logical break here. So there was a question from Nora, I think.
Yeah, I apologize if I interrupted you, Ivan. I just was wondering, when you submitted this paper with this very important, in my opinion, finding, when you were submitting it to PNAS, did you realize how important that finding, or actually it just kind of navigate you in order how to kind of frame it in a way that the audience will understand that that's why it's important? Because it seems like the research design is very simple, it's super straightforward. It's huge amount of data. And yeah, I was just wondering, when you were submitting, what was your thought? Or did you expect?
Yeah, so I think we should also ask Lisa, because it's interesting if we have different perspective on this. So I think I was, yeah, we submitted, I even don't remember that we submitted in science, but science is just, yeah, you should not, I mean, you should not submit. So I don't think that I was thinking that this is important, but I was thinking that this is not, I mean, this was nice results, especially because this was so clear line across all these age cohorts. It was like, I don't know, and I also have the feeling that it has a chance to be submitted. I think that's why, because I was reading a lot of papers from kind of PNAS and computational social science and Nature Human Behavior and similar journals. So I think I have this feeling what can be published. So I have this feeling that it could be published there. And I think that was also important, because I think that's why we spend more time on this, because sometimes you just, I don't know, sometimes you're just lazy and you become sloppy. And here, because I think we believe that this could be published there, so we really, I think we spent a lot of time on like polishing the final version. Like if there was this, sometimes I submit papers and I have some sentences that are not so polished, I just say whatever. And I think we actually made sure that we don't have such sentences. But also, I think that maybe, I don't know, I'm wondering what's Lisa's perspective on this.
Yeah, I think that we framed it just in the first draft of the paper, like in the first version of the paper, we have already framed it. Like we don't just simply describe the results. So we, in the significance statement and in the discussion, we said why do we think that it's important that yeah, these results that we have uncovered. But yeah, but these suggestions from the reviewers, from the from the editor, they these suggestions, yeah, they really helped a lot. Yeah, but without this framing, I also think that like maybe yeah, the results will be much yeah, they would look much less interesting. Yeah.
Thank you so much.
Yeah, so Lisa reminded me about the significance statement. So that's also like PNAS has this, you have abstract, that's 250 words, and they also have significance statement. I think it's 150 words. So they require you not just to write. This is also true, I think, for, no, I think that this exact format is unique to PNAS. They ask you also kind of to justify why you think that your results are super important. And for all the selective journals, they actually require your results to be important. And yeah, during like this question, I can talk a bit more about this, because it's really I think this is a very bad thing, because this is kind of highly subjective, and this, I think, a very easy way for people to just discriminate, just because you have this. So usually in these journals, you will be just rejected by an editor. You won't have any reviews. Your paper will be just rejected, and they will just write your paper. Everything is good. It's just not important enough. And I mean, as you can imagine, such things are just, I think we know it from social science, that if you have such things, it will be used for discrimination, because if you have this highly subjective, very strange way to formulate a rejection, that would be used just for people to use against everyone they don't like. And that's yeah, that's from my second part that I don't know if we will even talk about it, but there is another question from Sangam.
Yeah, thanks, Ivan, for a very interesting talk on the subject. My question is related to the reproducibility aspect in social computational science. Say tomorrow, because as I see from what we are discussing, there is a very heavy reliance on the social media data, especially when you're referring to VK. And tomorrow, if you have a policy changing around the VK, and you're not able to collect even the data that you possibly had today. So how much of that would be kind of considered as like your research is not reproducible or something like that? That is what I wanted to understand.
Yeah, but maybe could I answer your question maybe after I finish this first part, because I'm not, yeah, I think it's a bit more general, but that's very, because I think I just have a few slides for this first part.
Okay.
Yeah, that's if I want. Yeah, that's what I just, yeah, it just was related to this theory component. So because I have this question that's a bit. I think I was used it when I was presenting this for a computer science audience. Just I wanted to be a bit provocative. So but that was questions that I was really thinking a lot about. So I was studying this mathematical faculty of St. Petersburg State University, and this is like, I think, very selective faculty, and there's so many smart people, much smarter than me in mathematics. They was just, just super smart. I mean, I think there couldn't be no doubt that they're highly intelligent. They would probably score a lot on IQ, but then when they start to talk about kind of social issues, they just produce like nonsense. And I was just, many of them, and this was like a mystery for me. I don't know. I think there's not so many things that are real mystery. So in science, we often pretend that this is like very important, but not really believe in it. But that's for me was like very interesting mystery. And then I have a hypothesis. I don't know if it's true, but my hypothesis is that the difference between like social science fields and this mathematics, physics, computer science is that in this kind of hard fields, there is all assumptions are always explicit. So what actually mathematicians are good at, they are good in, like, if you have this initial assumptions, I know axioms in mathematics, laws of physics, then they're super good and intelligent in creating these logical chains and of arguments. And these logical chains would be very precise, so they're good in not making errors in these chains. But the problem is, it's not really helpful if your assumptions are wrong, right? If your assumptions is wrong, then you can be super logical. You could be right in all your arguments. You will still come to wrong conclusions. And this is very easy to see if your assumptions are wrong, because you don't actually even, in mathematics or physics, you don't usually make any assumptions. You just have these laws. And if you make these assumptions, they're always explicit. You say, okay, let's assume that this, we have this set of axioms. And in real life, a lot of these assumptions are implicit and they're invisible. And that, I think, what really makes people, blind. And just to confirm this hypothesis, I also was looking at this, was thinking about Nobel Prize in economics. So I think in a lot of cases, the Nobel Prize was awarded not for people who were just smart in mathematics, and mathematics is important in economics, right? But not for people who derive the most smart equations. That's basically for people who say, we all assume something and maybe this is wrong. So the Nobel Prize in this behavioral economics was for people who say, we all assume that they're rational agents. They say, maybe people are not rational agents at all. So they challenge this assumption and they get Nobel Prize in economics. So that's how you achieve success. And that's not only one example. There's in my field education, there is this famous example of signaling theory. So Mike Spence was receiving this Nobel Prize in economics. So his idea was, we believe that graduates. So what we can all agree is that graduates from the best universities, they kind of performing best in job market, and we believe this is because probably this best university prepares them very well. to the job market. And they say, maybe that's not true. Why we're assuming that, and that he actually show, and there is some actually complicated mathematical theory behind, but he shows that probably it could be not the case. It could be that universities just play some signaling function. So just a very hard to obtain, very expensive signal. So basically universities select the best students, and then as a result, they have this best graduates as outcome. And so this is basically just a sorting machine. And I think his contribution was also like showing that this would work. This cannot work with like certificates or some sort of things because they would be cheap, too cheap signal. You can easily fake certificates, or you can not directly fake. You can train for exam. Just sitting, and that would be a very bad signal. But if you require people to spend 5 years of their life, that would be expensive enough signal kind of to work in this way. So anyway, I think there was also some other examples. So you just finally realize that some assumptions are wrong. And that's where I believe this theoretical thinking is really useful, because like in social science, I think many of the theories are also just saying, maybe just everything works in different way. I don't know. I really big fan of Bourdieu, and I think that's the only sociologist whom I read, like not on Wikipedia pages or just some heard from some other people, just someone that I really read, like even in French. I think one paper I read. And I think that also, I mean, his theory is just about saying, that's maybe what you see is, not how it looks like, and there is some different mechanism. I think, I don't know, we have also sociologists here, maybe they can say, but my feeling is that many sociological theories is about saying, maybe our assumptions are wrong, and let's look at it at a different angle. And that's why I think theoretical thinking is very important. That just train you to first identify implicit assumptions, because they're implicit, you need to be able to see them. And then it helps you to see what will happen with new assumptions. But I'm spending too much time on this. Yeah, so this is end of this first and the last part, actually, because I have some bonus slides, but that's for question. And now I can return to this reproducibility question. Yeah, I have actually many things related to this. First of all, because I want to just stay with this topic of publishing. So many journals, selective and non-selective, they ask you to make sure that your results are reproducible, and they ask you to share your data. And what is really annoying, that's really not working at all. So usually people say, there's privacy reasons, so we cannot share. We share something. And when people share this something, that's usually useless at all. So I was recently reading a paper. So what they did, they were predicting personalities from photos from images of people. So they developed this neural network algorithm, and they were predicting these personalities. And then I was skeptical. I even like reading a paper, and I'm just skeptical that it's possible, because their correlation was too high. That was higher than because we already know to what extent we can predict personalities from other things. We know what we can predict from images, and that from images personality, you can have this very good feeling of upper bound. And their estimate was higher than this upper bound. That was unrealistic. And also, I think from reading their paper, actually, I think I even know what they did wrong. I think they were overfitting. Overfitting is a complicated topic, because like in a simple way, you can always avoid overfitting, but overfitting can be on a different level. Like for instance, some people think that if they split data set in training and test, then they will avoid completely overfitting. But then if you try 10 different models, then you're already overfitting when you select the best model. So you actually need to add some additional separation, etc. And so the journals where they published, that was Scientific Reports, and they're kind of very pro-open science, open access. They require you to publish data. And what they publish, and they publish something, and they say, privacy concern, blah, blah, blah. What they publish predicted values of personality, just results of their model, and personality scores. this completely useless data. I mean, that's data completely useless. I was even thinking about kind of fighting to get access. So, and then of course, like photos can be protected by privacy. That's okay. But then they could release the model, right? There is the model they could release, so we can all check. That's, I think, super reasonable. And they were not releasing this model. Yeah. So often it's just, a joke, not a real reproducibility. But I think there was another part of the questions related to this kind of changes. Yeah, and that's a hard, I think the question is, I'm not sure, but maybe the question is just, we know that this is kind of true today in this particular environment, for these particular users. Do we know what will happen, tomorrow? Even if in the same settings, but just tomorrow. Yeah, I think we don't know. There is hard to make any guarantee. But I also think that I also have a set of slides. So what I show you here, this was slides for computer scientists, just to annoy them. And I also have another version of this talk where I have slides to annoy social scientists. And there I'm talking about the obsession with representative samples, this random sampling. And then so there I say, you are so obsessed with this, but there is like biologists and they do a lot of research on bacteria. They're not doing representative sample of bacteria from all over the world. They just study bacteria. And then, and I'm asking, why they do this? And they do this because they have no reasons to believe that, E. coli in this part, this E. coli would be much different in respect to what they're studying to another E. coli. And that's, I think, so conclusion for me is that we cannot say that something is not representative just in vacuum. We can say, we can always provide a reason why we believe, and the reason why we cannot do this just because that would be unreasonable burden, that no study can satisfy these requirements, like super pure requirements, it's impossible. So this burden is unreasonable. So I think that what we should do, if we have a reason to believe that these results will be different, then this is kind of a legitimate concern. Then we say, okay, now we're thinking, okay, so you're not just saying that tomorrow is not today, you're saying that tomorrow we'll have this, this, and this. That's why the results maybe no longer hold. That would be a valid concern. And if you have this valid concern, then please go and do this study. And that's how science should work. So you should not criticize any study with this unreasonable requirements to have everything like completely random sample, and it's also like not observational data, but some like super experimental data. You should just be very careful in your interpretation, of course. Then you have also always have to think about what could go wrong. And if you have this idea, then you should conduct new studies. And that's how science would work, because this is never an individual effort. This is just a collective enterprise. Yes, so I have this kind of bacteria part was to annoy some social scientists. I use it. I think it works. Both these things, things annoying computer scientists and social scientists, it usually works. So they usually, some of them become annoyed, and that leads to interesting discussions. Yeah, I hope I answered this reproducibility question to some extent.
Thank you, Ivan. Even though the last part of what you said was like, it was out of the context in some ways, but I guess you answered the most relevant part.
Yeah, I'm a big fan of out of context things. So I'm teaching a course, starting to teach. So there is a course in my university, and I'm teaching the last part of it. And I was preparing to it, and I was reading student reviews to this course, like previous version where I was not involved. And they say the teacher spent too much time on irrelevant kind of content. And I was a bit annoyed because I think that is actually, for me, it was the most valuable part. It just sometimes, I mean, these irrelevant things are usually, for me, when I'm listening to something, I think I often remember these irrelevant things, not, yeah. So I like irrelevant.
But you teach
saying
in
irrelevant things.
Germany, Ivan, in Germany.
Yeah, that's already, yeah. So now you say you teach in Germany, and now I know what it means. That's yeah.
Okay, thank you, Ivan. Anyways, thank you.
That's obviously not aligned with my spirit, German education system.
So, do you are you going to show us the last part, or do we stop here with
Yeah.
your talk?
Yeah, I don't know. I know. It also depends how, I mean, how everyone, what's the mood of people. I think.
So we have
and what was planned? I think it was planned to be an hour, right?
yeah, it was planned to be an hour, so like we are 5 minutes late, but I guess.
But also other people have more time. But that also I think that because I asked it to be short.
Yeah, you asked it to be shorter. Yeah. I offered you the same amount of time. Yeah. Okay. So we have. I guess that we can have like 10 minutes more. So if you guys have some questions, you can ask Ivan, or we can hear the last part.
Yeah, maybe I can like briefly just show you.
Okay.
It's less interesting, but the idea, so I actually wanted to start with this first part initially, but then I saw that I maybe won't. But I like the current first part more. That's why I decided to start with it. So I just wanted to provide some context for this thing, and then I think that also like people were asking like where people publish, etc. And I wanted to focus on this general interest journals. And so many of computational social science papers currently published there. And I will also say that why, and in any case, like even, and the point is like, even if you're a computer scientist and you publish in your computer science conferences, you usually want to publish in these journals because they're like prestigious, etc. And social scientists, they publish in their journals, but they also want to publish it here, and criminologists and political scientists, everyone wants to publish there. Because this is not good, but this is how it is. And that's why I think this is kind of really relevant to talk about these journals. And then I was just saying that, I don't know, there's some really old journals, really new journals, this like journals like PLOS ONE Scientific Reports. There's this mega journals, they have a lot of papers, and they're not so selective. So for example, for Nature and Science, this selectivity is 7%. And I will tell in a minute that this 7% is not for us, not for mortals. This 7% is for Sune Lehmann and René Kivzičić. And there is some of them are not really selective, but also they are okay. Yes, for Barabashe. I know some famous authors they doesn't take no as an answer. So I know like people they say, your paper is rejected. They just call it. They say, are you like in your mind? I will stop collaborating with you. Stop talking with you. Please reconsider, and people reconsider. And this is just true story. That's crazy. And so in journals like this PLOS ONE Scientific Reports, they're not very selective, but they're also kind of okay. Nobody will, if you have only PLOS ONE papers, people will say, that's this guy is suspicious. But if from time to time, it's okay to publish there, and this is a good way. I don't know, if for some reason the paper doesn't fit anywhere, but you really like the results, you want it to be published. And also papers in these journals could still have a lot of media attention and cited, so that's kind of okay to publish there. And the prestigious journals, so people usually want to publish there because they get a lot of citations just automatically. I think that as people should not do like this. They should really care about the content of a paper. But then people say, okay, this is suspicious journals, maybe I shouldn't cite it. And then you can find a lot of papers that cite only this Nature PNAS science papers. That just again reality. Also, a lot of media attentions are for these journals. And that I think also the problem for some people who publish in their field. So there can be like very selective economic journals, very selective social science journals, etc. Very prestigious, selective, and also important for this career. That's the last part. But media attention is usually not there. People usually want to have some media attention. And unfortunately, this is also important for your career. Like if you have 3 papers in these journals, your career would be okay with just empirical rule. And that should not be the case. And that's actually officially recognized that this should not be the case. There is this declaration, DORA, and the first bullet of this declaration say you that general level metrics should never be used like for promotion decision, for like paying you, etc., etc. And there's a lot of signatures, like a lot of universities sign this, and that's not how it works. I mean, I don't know, show me any selection committee that would ignore this that you published like in Nature. That's, I don't know. I know none of such selective committees. Yeah, but it's, I don't know, at least, I mean, I know, I'm trying to remind at least that it's officially wrong, but maybe we should all sometimes remind other people. But before that, we should also take into account the reality. So also the journals have like a very specific format. So usually they're very short papers. For example, for science, it's just 2,500 words, and that includes everything. And then how it usually works, because people don't want you just to skip all details, so you have this supplementary information section where you put everything. This can be like 40, 50 pages sometimes. So you dump everything there that's not in the main text. I think that's not how it works for computer science conferences. It's different format, and I think that's for many domain-specific journals. That's not also like unusual format, but that's how it works for these journals. Why I'm showing this? What is this? Here I just wanted to show that introductions are also very specific, right? So in the social science journal, sometimes people say, write us please 4 pages of introduction, and just when you make a reference to something, you just explain what observed there, etc. So this is a very specific format. And for these journals, this is a typical introduction. So you write 1 sentence, like people, friends, social ties tend to live longer. And then you have these few references. And then again, that's how it typically looks like. So, and this is also like even not the most packed. So sometimes here you see not 1.4, you can see, I don't know, 1.8 here. And here would be also like 8. So this is, and you can open many papers from the journals, and you will see this is a super typical example. So it's just how people work here. And I think it's good. I like these introductions more. Also because I think that the problem with introductions, because there is one introduction could be good for many papers, because many papers could explore the same topic. And so when we are required to write these 4 pages reviews and introductions, it means that taxpayers' money are spent many times for the same thing. So I think that reviews are super important, but let's have the special format reviews, so that people really work and create these careful reviews. And when we just present empirical results, I think it's good to have the short introduction, and then we can reference review, and people who are interested in reviews will just look at this review thing. Then also I want to tell that abstract is like super important, and it seems logical for, I don't know, when you start to do research, it seems logically, I just do some research, I described everything in my paper, and then I finally summarize it in an abstract. This looks super logical, but as a result, you will have, what you have, then what you have, that's kind of so-so results. And this is not how it should work. Your abstract should be perfect. That should not be, so it should be really perfect, better than your paper. And the reason, because how people read papers. They start with the title. If they think the title is not relevant, they will just not continue to your paper. That's also important, that you should think about your title. It should be, you want to attract people which are relevant to your paper. You don't want to miss relevant people. Then they read abstract, and again, if abstract is, they don't like abstract, they will stop looking at your paper. That's why abstract should be really perfect. And these are, the requirements could be pretty strict. Like for PNS, it's 250. For science, it's even 125. And for PNS, you have larger abstract, but you also have to write a significant statement that's somewhat similar to abstract. That's 120 words. I don't know if you ever tried to write something 120 words. This is like super hard. That's and writing so these science abstracts and P&S significance statement, it's like super hard. It's really, you just write one sentence and you already have no words. But fortunately, there is a typical structure. And maybe I don't want to spend too much time, but there is kind of typical structure. But what is interesting is that really, so I think this is from some MIT materials. So this is just usually one sentence related to general background, one to specific, one to knowledge gap, then here we show the results. And what's interesting is really how universal it is. So it was harder to me to find abstracts in these journals that really don't follow this structure. Here I have this example, but I don't even know, I don't know. So you see they say social interactions increasingly takes place online. This is kind of this general background. So we're saying that what's going on. And then people say, in the next sentence, they actually cover two sentences. They say that friendship and ties offline social ties associated with human longevity. So that's saying more specific content. And then people say, what is the problem with this knowledge gap? They say, but that's maybe we don't know how online works. And then I will skip it, but just maybe I can share a presentation. You can just do this exercise yourself. You can just check and you see that really everyone is following this. And we, I think, also will follow this in our paper. This is just, and also the thing is, some people think that it's nice to be creative in these things, but I think sometimes it's not nice to be creative. In these things, it's kind of good to follow some existing formulas when you write in the papers, also because this is not literary fiction. This is scientific communication, and you want this communication to be effective. And when people get used to the structures, to the specific formulas, etc., it's just easier for them to read. It's just easier to understand, because imagine like you usually have to scan a lot of papers, and if the people just decide on their own creative way to present things, you will spend time kind of deciphering this. But what's really important is results. So your results, that should be, you know, creativity in your projects. You can have like new interesting ideas how to do this. But in this writing, that's you just want to follow these formulas. And then I have this magic formula for academic success that says that you need to have just research skills. That's obvious. Then that there is some hidden knowledge that's not so obvious, and that's this abstract writing is one example of. It's not like super hidden, but you need to know that there is a certain structure for these papers. And another component that's, I think I already covered like sometimes today and before, that this prestige component is kind of important. So if you are from prestigious university, you will have high chances to be accepted. And that's if you already have a lot of good prestigious papers, that again, your chances are high. And if you don't have this, then the only thing that could help you is luck. So we were outsiders. And so I think that's why, like, for sure, luck was an important component. So what I'm trying to say by this formula is that if you are doing everything right, that's not enough in this competitive science environment. You won't be successful if you're just doing everything right. So you just have to be lucky. And I think that Sune Lehmann, I mean, that's nice that Sune Lehmann actually said the same thing, that luck is important. I think he said that he knows people who are smarter than him, but not as successful. And then sometimes if you already have some prestige, then you might not need luck. So if you're a graduate from, I don't know, Harvard, you probably can do well without luck. But you still need, of course, research skills and all this stuff. And then hidden knowledge can be obtained. Yeah, so you can, there is some books. So I recommend really this book. So I recommend it a few times in recent days. This is, I really like this book. It's about how to write a scientific paper. So this is also actually a computational social scientist. Has more computer science background, but he's doing some social science related things. And he also has this blog. So all this book was written before as a series of blog posts. So you can find it for free. You don't need to buy it. And another way to obtain this hidden knowledge is just to read a lot of papers. So I mentioned you this pattern with abstracts. So I believe that if you read a lot of abstracts, you will be able to see it. It can be not so easy when it's not explicitly stated, but I think you can get pretty good understanding of how this papers looks like. And the best way, of course, is to find a mentor. You just work with him and or her, and if they are already experienced in this field, they will teach you anything. That's why it's really important, I think, to have, if you're thinking about PhD or like postdoc positions, that would be very important to supervisor. If you want to publish, like if you want to publish in PNAS, then you have to find a supervisor who already published there. If you want to publish in Nature, you have to find a supervisor who already published there. Otherwise, your chances are not so good. And that's, I think, this nice empirical result related to this prestige component. So this is a paper. Actually, Sune Lehmann was also one of the authors of this paper. So what they were doing there, they were looking at this like papers in some prestigious journals, and they were dividing papers on like 3 types. So the first type was when there is so they were looking at the senior author. Senior author is usually the last author. There's usually the first author is usually the person who made most for the paper. The last is like the most senior. So there's some conventions regarding this, not strict, but they exist. So they were looking at senior authors who publish for the first time in Nature, let's say. Then they were looking at this established. It means that they already were publishing before, also as the lost author. And they were looking at this kind of what they called chaperone. This is, I think, from some French or maybe Italian word related to this, usually women who were following young girls. Anyway, so this is just people who were already publishing there, not like a senior authors, and now they're senior authors, and the idea was that they kind of learned something from these more senior authors. But what was interesting in this is the statistics that they have. So like for Nature, for example, you see that more than half of authors, that's already established. So that's what I was saying, is that this 7% are not for us. So because most of the papers, that's for authors who already published there as senior authors. So as people joke, I mean, like the best way to publish paper in Nature is to publish paper in Nature. And that's just empirically true. And then also many of the rest, like half of the rest, is also people who already published there, just not as the senior authors. And that's left very few for these new authors. And also this is not necessarily, because of their definitions, it's not necessarily completely new. And also they can be like chaperoned in other journals. Like, so maybe you publish for the first time in Nature, but before you have paper in Science, so you publish it for the first time in PNAS, but you already have Nature of Science. So for these new authors, there is really, I don't know, at least 10 times acceptance rate is less. So if it's 7% for Nature, then for those, I don't know, maybe some of you already have Nature papers, but if not, then that would be for us 0.7, not 7. And partly this can be explained by this knowledge, right? I think maybe it's just really important to have some hidden knowledge. So, and these mentors share with you this knowledge. But I personally believe that partly this is also explained by the fact that if you are just this established famous person, you have much higher chances to be accepted. And I already was complaining about this editor's decisions. And so here I just decided to give some examples from my own rejections. So that's just so you know how it typically looks like, right? So when I was starting my life in academia, I thought, okay, I will get rejections because reviewers will say your paper is bad. But no, that's my paper rejected because it was not given a high priority rating during initial assessment, whatever it means. Who knows why? I mean, that's nobody could tell me. And then another rejection was that it was not sufficiently striking. Yeah, so sorry, your paper is not sufficiently striking. And then recently I get this very nice answer from PNAS. They say no bad things, and they even say some personified good things. So it seems like the editor even read paper and like something about it. There was some like saying that discussion was kind of nice and model was nice, but it's not enough of an advance. again, how they decided, that's nobody knows. So, and I believe so if you are not part of editors networks, so your chances are smaller. If you are not from prestigious institutions, I think there's also some empirical evidence. Actually, I wanted to prepare at some point a better empirically grounded talk on this topic. I think there is some research on Science of Science that actually show this, that this is true. And then if you're not from US, UK, you also disadvantage. And that's I have like a lot of funny examples on this. So when we publish this, try to publish these papers with like millions of users, they say, you know, why you are not saying that this is from Russia? That's like super important. Please indicate that this is from Russia. Please add it in your title. If you title, you just try. I mean, I think that when people were discussing our parents' paper on Reddit, someone say, so authors really lie to us because they didn't indicate in the title that this is from Russia. So this is. So they're trying to, you know, kind of, how you say it in English? Yeah, they say that we are lying because we didn't put it in title. Even like in abstract, it exists. So in abstract, we described exactly where the data come from St. Petersburg, but they were complaining about the title. And we have a colleague, I mean, who I think told us that once he was working with a data set of all high school graduates from China. And he said that his paper was rejected from a conference. And people say, because this is like, you know, too specific sample, you know. I guess, I mean, so if you have 1 million people, that's too specific if it's from Russia, from China. But then we all know a lot of papers that come from some studies that was done on, you know, 40, 50 US undergraduates. And these people never say, I mean, sometimes say, but most often they would never say and bother about saying this is from this university. They just say, you know, we discover that humans, I don't know, who like cats also like something. Yeah, sorry for this complaining part. So there was a question. Or...
Just, Ivan, I just wanted to add that we have exactly the same problem with the German sample. Like, it's not only like about Russia and China, it's about US versus the rest of the world. This is just my impression, because we have a paper where we had to say that it's not really German, it's really kind of like Western Europe. So we're really trying to avoid Germany in the abstract because we're preparing a paper. There's kind of general interest, but yeah.
Yeah, so that's also, yeah, that's also true for Europe. I mean, that's nice that, I mean, yeah, I also was talking a lot of this colleague in Europe. There's also this bias even against like continental Europe. I think for UK, it's a bit different. UK is kind of in this US category, but for, yeah, so I think it's very easy to, we can just, I think we can Google something like, you know, evidence from, and just put country names and just see how many we have like from Netherlands, Denmark, Russia, China, and then that would be much less often than from US. So people don't say evidence from US. There's even sociological term for this. I think it's called unmarkedness. So you have these unmarked categories. So for instance, like often men are unmarked categories. So by default, you're a man, and then you have to specify that you are a woman. And then by default, you are white, and then you have to specify if you are not white. By default, you are from US, and you have to specify that you are not from US. I think we have some US-based people. I hope that they are not.
Right now, no.
Okay.
But probably we will upload your talk on the site. So
yeah, actually, I have the last slide. I just want to, it was also interesting when I learned that, you know, that people, that was interesting revelation for me when I learned that sometimes people hire some of these famous professors, they just hire professional designers, and these professional designers prepare the plots for them. So when you were looking at these papers and you see the super nice plots and you wonder, wow, how they were doing this? Maybe they are talented themselves, or maybe they have like very talented PhD students. So sometimes this is just designed by professional designers. And I also learned that some people just, I know, if they don't want to spend too time by formatting their papers, and that when you submit to several journals, you usually sometimes need to reformat everything. Even if you're working with LaTeX, that's kind of simplify you this reformatting. You can just, it's still, yeah, I mean, there's hard to avoid this. And I learned that some people just hire people just to do this. So they're not part of this. They're not co-authors. They're just some people who are paid just to do this formatting job. And I cannot afford this. So not all of us can afford to hire people. and we are, of course, at disadvantage. Yeah, I think it's kind of important to remember about this. I don't know what to do with this, but
and this is also not like it's not it's completely not reproducible. So like you can't reproduce the plot if it was made by a professional designer, right? So if it was like the plot should be made with only with code, right? Not with like some.
yeah, but it's I think that's mostly related with like very nice network visualization. So that's usually that's probably not for this results part, but there's this, sometimes you have this impressive. So also like Sunil Lemon, I think, was mentioning that his work was on this cover, right? So and I think sometimes you see this very impressive visualizations on the cover. I think the journal sometimes can also help you with this, but also sometimes they ask you to submit this cover image, and then yeah, I never submitted this cover image because I never have any good plot. Just I mean, I don't know. None of my plots were looking like cover image. And then these people who hire these designers, so their first figure usually is introductory figure, like with some cool network things. I don't know what papers is there any papers that everyone knows? There's just like, I don't know, papers from the paper, I don't know, do you know this paper when people were studying museums and how artwork moved from, I think this is from Roberta Sinatra, and I think Barabasher was also, and they have very obviously not standard paper. Probably that was, this sort of papers probably was created by designers. And this usually kind of first figure, so they're really prominent in the paper. And that's, I think it impresses. Yes, yes. So yeah, this sort of, yes, that's usually, that's also one thing related to this format. So usually there's also some conventions. So usually a first figure in this, it's usually not a result, it's usually some introduction. Sometimes it is design, as Nora was saying. You can just describe design of your experiment, and this can be very beautiful pictures. Yeah. I think there was one hand, it disappeared, but
yeah, Sangam. Yeah, Sangam wanted to ask something.
Ivan, I just wanted to ask, even though controversy is one of my favorite subjects, so I just wanted to touch upon one of the slides wherein you put the disadvantages. Are these coming from your own experience, or is it like a generalized statement that you are kind of?
So that's come partly from just my experience. That's also come from talks with so I wouldn't, because I mean, I wouldn't say this if it just, just my experience, because my experience is just, I don't know, maybe I'm just, very bad scientist. And then I'm just trying to find, ways to justify. So that's why I would never just say that it's just only from my experience. There's also, I talk a lot with my colleagues from mainly European countries. They all more or less agree. And I think that even, yeah, I think everyone more or less, I mean, I think there is actually consensus about this. So if you say, yeah, we can, I don't know, we can ask our next speaker, guest speaker. I think they agree that this is true. This is discussed a lot on Twitter, etc. And I also believe that there is an evidence. So that's why I'm kind of sorry that I don't have empirical evidence. So I remember there was this study. So what they try to do, they try to look kind of at this, your prestige, like given your like previous achievements, and they try to control. It's kind of hard to say, right? So maybe these people were very successful before because they are smarter. And so they were trying to control for that. And they observed that like your previous achievement, if you kind of control for your skills, that was hard to do, but there is this, was this paper that was trying to do this. That's really significantly increase your acceptance rate. So that means that not papers are not considered independently. And from US, UK, I think it just also you can just clearly see this statistically, this bias. Yeah, so I personally believe that this is true and that we even can show this empirically. I don't know if anyone disagrees.
Thank you for your perspective. I guess there cannot be a disagreement. I certainly don't know whether it's an agreement or a disagreement, but certainly it's a view, and that view could be what you are portraying it here as a disadvantage.
Yeah, but thank you, because it's kind of, I think I wanted for a long time to, when I talk about it, I wanted to add more empirical things. And thanks to your question and comment, now I think that it will be high in my priority.
Yeah, but the reason specifically I asked about it, because I primarily I look at things from a very different perspective than what the academia people look at. I look at from the industry standpoint. And also just very recently I completed my master's in UK. So I got an opportunity to work with a lot of professors. But having said that, working with the professors and getting your publication through in any reputed journals, or maybe what you are portraying here as a disadvantage, I guess I am looking at in a very different way than what you might have already experienced in your academia career. So that was where the question was coming from, actually. Okay.